Good afternoon. So yes, today is about meta-programmable functional notebooks in Livebook. So the first question is, what is Livebook? And Livebook is, I like to think as the next generation of open source computational notebooks. And then you may be wondering, what are computational notebooks? And they are a tool for, you can have code, documentation, and rich visualizations all living together side by side. And Livebook is open source. You can install it in your machine. That's what I have running in front of me right now. And the whole presentation, it's a kind of live coding presentation happening inside Livebook, so what could go wrong? And and my goal is to show how Livebook works, explain some of the design decisions behind it, at the same time that I'm talking a little bit about the internals and how it is designed. So if you run Livebook on your machine, you're going to get something like this. And I have the presentation here. So the first look that we get, right, it's like, oh, yeah, it's like a document. We have some code. This initial part is always about dependency management, which I'm not going to talk about today, but it has built-in dependency management. And what we can do is that, yeah, we have documentation, and we have code, and then we can start executing this code. So in order to talk about Livebook, so Livebook is implemented in Elixir, and it's focused on the Elixir programming language. So if you want to talk about Livebook, one of the things that we have to do is that we have to talk about Elixir itself. So who here has already programmed in Elixir, even if a little bit? Okay. Most of you. So I'm going to go very quickly through the introduction, okay? But I'm going to get all the important concepts. So Elixir is a functional and dynamic programming language that runs on top of the Erlang virtual machine. So as a dynamic programming language, I can, for example, create a list with 3 elements in it, a string, a number, and an atom. And the data structures in Elixir, they are immutable. So if I go here and I try to delete something of the list, we can see here that it no longer has the number 1, 2, 3. But if I access the list itself, right, the list is the same. We did not mutate it, right? We just returned a new one. And there are a bunch of features in Elixir that we could talk about, but the one that is important for today is the ability that Elixir inherited from its platform for their Erlang virtual machine, which is the ability of creating processes. And those processes, they are very cheap, lightweight thread of executions, and we can literally create millions of them. So here, I just created 1,000,000 processes. I spawned 1,000,000 processes, and I did all of that in 3 seconds. Right? So we can create like a bunch of those, and they are all isolated, and they are all running at the same time. Right? So we get isolation and concurrency from them. And one of the cool things that we can do with processes is that we can communicate. Because they are isolated, we need to have a way for them to like collaborate, for them to do something together. And they do this by communicating. So here, let's go for this example. Let's break it down a little bit more. So here I have the spawn function, all right, that starts a new process. And inside this function here, I'm going to create a new process that is going to receive a message that matches on this format. So it's a ping message. And what we do that when we get this message, we are going to send to the caller a pong message back. So that's the child process. And then in the parent here, I'm going to send a ping message to that process. And if it all works out, passing myself the reference to the current process, and if it all works out, I'm going to get a pong message back, which I receive, and then I print it. So if I execute this, it says it worked, because I spawned the child process, I've pinged it, and I got a pong back. But one of the cool things about Livebook, and one of the cool things about thinking about programming in a rich environment, is that, well, you know, I could try to teach somebody Elixir, and I can show this code and have them build this like intuition about processes being spawned and messages going back and forth. But because Livebook is a rich medium, what I did here is that I got all that code and I wrapped this in this function. And now what we get when I execute this is that we get a diagram showing exactly what is happening. It's like, hey, I spawn a child process, right? And then I send a ping message, and I got a pong message back. And now I no longer have to necessarily build all the intuition in my brain. I can start looking into things, right? And it's not only about, hey, I'm learning Elixir. So if you're an experienced developer, if you use Elixir in production, for example, there's a chance that you use this function called async stream. So what async stream does is that imagine that you have 4 URLs and you want to get information from them. If you don't want to go one after the other, you could like put them in a list and say, hey, I want now to process each of those URLs like at the same time concurrently. And async stream is a mechanism for us to do that. So we can emulate this. So let's say, okay, I'm going to have like 4 entries, and I'm not going to access a website. I'm going to sleep for a random amount of time with a max concurrency of 4. And then you can use this in your code, but you may be wondering, hey, how does that actually work in practice? Right? So you can go here, you can come to Livebook and say, all right, let's just wrap that in this thing that renders the trace for us. And we can actually go and look at it and see how it works, right? And if you think a little bit about before, we were like, okay, if you're going to generate a diagram, I expect that diagram to have like 5 columns at least, right? 1 for the current process and 1 for each process that is going to access a URL. So, and then here we can see that we actually got 6. And then we can look at this and try to understand, oh, I can see here that I immediately spawn a process, right? And then this process is actually the one that is spawning all the children. And because they sleep by a random amount, you can see like the first one took really long, the second one was a little bit different, and every time we execute, you're going to get a different profile. But again, the idea here is exactly that we can start looking into things and understand how they work from really afar and start introspecting and understanding the system, all by using a Livebook and trying to integrate the code with documentation and rich visualizations. Something else that is really cool that we can do in Elixir, again, thanks to Erlang, is the idea that not only we can send messages between processes, those lightweight processes running the same machine, we can also send messages between processes running on separate machines, or even different Erlang instances in the same machine. So imagine that we want to have a distributed hello world. So imagine there is a distributed module and there is a hello world function in it. If I call this, it doesn't work because there is no such module, there is no such function. But what if this distributed module was defined in another notebook? So wait, I did the wrong thing. Hold on, I need my tabs. Okay. Yeah, so let me just show again that there is no sleight of hand here. So I execute it again, there is no module, there is no such thing. So I'm going to go to another notebook. I just open it, it's just fresh, right? And you can see that this notebook does 2 things. It defines a module called distributed, and it prints the node name and the cookie name. And that's because each notebook, when you run it, it gets a separate Erlang VM instance, a separate operating system process. And so if I execute this notebook, it's going to define the module for us, right? And then it's going to print the node and the cookie. And the reason why we know those are different is because if I go to the original notebook and get the node name, we see that they are different. So those are different nodes. And I executed the other notebook, and this still does not work, right? I can still not do this. But the cool thing now is that I can use Livebook to ask for some inputs. So I'm going to get the node name. I'm going to get the cookie name. And what this code is going to do, just high level, is that it's rendering the input and saying, hey, read the node name for us, read the cookie name for us, and then after you get those 2, set the cookie for that node, and then execute the same thing, distributed hello world, in that node. And now if I execute this, it works, right? So this is a very quick example of showing message passing across different Erlang VM instances. And they could be in different machines as well. And the cool thing is that the I/O that was on the other notebook, it actually went back to the first notebook, right? Because it knows that, oh, the request started from here, so the other node knows that if there is any I/O, it needs to send it back here. All right, that's the Elixir introduction that we needed for this talk. So now we can talk about Livebook. So one of the things about Livebook is that we have truly reproducible workflows. So has anyone used Jupyter Notebooks before? All right, that's great. Yeah, so Jupyter Notebooks, fantastic for popularizing the whole idea of computational notebooks. And if you talk with somebody who uses Jupyter Notebooks, they're going to say that one of the biggest concerns that you have in Jupyter Notebooks is that they may be hard to reproduce, right? So I can write a notebook, I can share with somebody, and they may get a different result than the person who created the notebook. And what makes notebooks hard to reproduce? There are two sources. So one is the out-of-order execution. So we've seen like notebooks, they are full of code cells, right? In Jupyter Notebook, I can execute a cell in any order. So I can get like a notebook, and I can first execute the third cell. And if the person who created the notebook executed another cell first, now you may potentially have a different result, and that may be hard to reproduce. And the other thing is that notebooks, they often have a global mutable state. So for example, in the Jupyter Notebook, you can think that the way it works is that you have the Jupyter Notebook, and it has some global state. And what each cell does is that it reads from this state, like it reads a variable from this state, does some changes, and then put it back into the state, right? So you have this global mutable state, and the cells, they are working against this state. And depending on the order that you execute the cells, you get different results. And there has been attempts to linearize some of those dependencies in Jupyter Notebook. So for example, hey, if this cell defines variable x, and this other cell uses that variable, so I know that I need to execute this cell before I execute that one. So there is some attempt to linearize and try to make those notebooks more reproducible. But the issue is that you still have the global state. You have not solved the global state. And so, for example, the proof is that if you go to a Jupyter Notebook and you say x equals 1, and then in the next cell you execute like x equals x plus 1, and then you execute the cell again, x is going to keep on incrementing, right? Which again, it's hard to reproduce. How are you going to share that with somebody? You're going to say, hey, here's the notebook, but remember to execute the third cell 3 times because that's what I did, right? So, and that's not only about variables, right? Any object that you mutate, it can be global mutable state. So in Elixir, that's not what happens. In fact, if I come here and I execute the cell over and over and over again, you're always going to get 2 back, right? And the reason for this is that you can really think of each code cell, all those code cells that we have been defining here, you can really think about each of them as a function. All they do is that they receive some state, which are variables and the environment, and then they return a state, but instead of putting somewhere global and mutable, they just pass it forward to the next cell. So it's as if you were threading a bunch of functions, one right after the other. And so they are fully sequential. You have to execute everything in order, and there is no global mutable state being shared between them. And the cool thing is that now we can use a little bit of static analysis to do like cool things. So for example, imagine that I define a variable again, x equals 1, and then y equals 2, and then another cell that is x plus y. Right, so these all work. And what I can do here is that if I change this cell, x, if I change the value of x, now I can track things and I know, hey, this code cell here is now stale because it depends on something that changed. But it knows that the cell in the middle for y does not depend on x, so on x. So I don't have to execute it again. I don't have to mark it as stale. So you're also like implicitly caching, let's say, based on that. right? So that's how we are trying to get like truly reproducible workflows in a way that you can do your experiments, you can do what you need, and then you share with somebody, and they are going to get the same result. But you may be thinking, okay, that looks interesting, but everything is sequential. Couldn't that be a little bit like too limiting? So that brings another idea that we have in Livebook, which is this idea of branched sections. So if you think like about a regular notebook, you're going to have the whole sequence, right? Like cell A, B, C, D. But anytime you want, you can create a branched section that say, hey, from the last cell of the section, I want to start a branch, right? Which we can see here in the diagram. So here I have a section 1, and then from the last cell, I have the regular workflow, but I can say, I want to start a new branch. And this new branch is now running concurrently, right? And this cell that I have, this section that I have here right now, this is a branched section, and we have this note here. Say, hey, it branched from that section. So this is really cool because now we are starting to incorporate the idea of concurrency into the notebook. So what I can do, for example, is that if I want to run experiments, I can have a section that does the setup, and then I can create a bunch of branched sections. They are all going to be running concurrently, doing their own experiments. So just as an example, I have this code cell here, and what it does is that every second, it shows me how much memory the Erlang virtual machine is using. And I can just have this running. And it's running there. It's running all the time. And because that's in a branched section, it is going to run forever without executing the flow of the notebook, as we're going to see. Something else that is really nice about Livebook is that we have this whole idea of a multiplayer runtime. And in order to show this, I want to talk a little bit more about the general architecture of Livebook. So one of the things that we can do, let me show you the example first. Let me open up another tab. And let me see if this is going to, wait. Let me select some text here. So one of the things that Livebook is collaborative. So I can go here and I say, take me to where that other user is. And we can see like, oh, that other user selected this code. And then I can see it here. If I go select something or I do some change here, it's going to reflect in the other notebook. So it's collaborative. Like a lot of people can go and work on the same notebook at the same time, right? And the way it works, so let's talk a little bit about the architecture. So you can think that each client is like a browser, for example. It connects to Livebook using WebSockets, all right? And Livebook is an Elixir application. It's implemented in Elixir. And they are connected to the same session that is representing the notebook. And now what happens is that, as I said, each notebook, it's a different instance of the Erlang virtual machine, okay? And we connect to that instance using the Erlang distribution. So this is really nice, because what we have is that we have Livebook, which is, it's a relatively, it's a medium-sized Elixir application. Right? But the runtime, the thing where you're running your code, where you are experimenting with, it's like it's just a started Elixir thing. So it doesn't really know about Livebook, and it uses the Erlang distribution, which was the thing that we used at the beginning of the section, right, to show how it can communicate through messages. So it's using the Erlang distribution to communicate. So that's a very nice separation of concern, where where Livebook as a server doesn't know what your code is doing. And what we have is that we have this library that is responsible for rendering the outputs, be them static or dynamic, which we're going to explore soon. So so I'm going to give a pause here because we actually already achieved one important milestone in the talk, which is meta-programmable functional notebooks. Right? So we saw why they are, why the functional aspect is important, because that allows our notebooks to be truly reproducible, and that's building on top of the language ability and that's building on top of the whole immutability aspect. We actually even went a little bit further, because the notebooks, they are concurrent themselves, right? So I could have said meta-programmable, concurrent, functional notebooks, right? So This is really nice, and we are seeing like how this can be useful as we are working and as we are producing documents. All right, so now we're ready to go to the next part of the talk, which is about metaprogrammable notebooks. Okay, so what does it mean to be a metaprogrammable notebook? And actually, to be honest, I don't know if that's a good name. I'm trying to make it fly, but we'll see. You can give me feedback after the talks, like, maybe that's not metaprogramming. So I'm going to show the problem, okay, what we're trying to do here. So one of the things that we have, that we are talking about processes. Oh, this thing is a process, this thing is a process, and then we have a bunch of processes running. And the other thing that you can do that is really neat in Erlang is that I can actually get a list of all the processes running in the system and ask information about them, right? So you have all this code running inside processes, and I can introspect them. So I have this code that does exactly that. It goes through the list of all processes, get the information of reductions, which is the amount of work they have done so far. Think about CPU work, the amount of memory that they are using, and their status, if they are running, if they are waiting to receive a message. So if I execute this, it's going to print like this large list with this data that we came up with, okay? But you can say, hey, you know, this is nice, but wouldn't it be even better if we could visualize this data somehow, right? And so how can we plot it, right? That's the question. And if you are like me, Livebook is a new journey for me. I know that we can plot stuff, but I don't really know any plotting library, right? So how can I do this? Maybe there's a library that I could learn, consult the documentation, get familiar with it. Or maybe there's somebody that is really good with plotting, like maybe they are very familiar with matplotlib, but they have never used Elixir before, so they have to figure that out. So in Livebook, we have this idea of smart cells. And we have one smart cell for charting. So I'm going to click on a smart cell. And you can see that it brings this UI. And it asks the data that we want to plot. So it automatically picked up the process variable because it knows it's the only variable in my whole notebook that it looks like it can plot it, that has data that it would be possible to plot. And then we can say, OK, all right, so the data are the processes, x-axis memory, the y-axis, let's put the reductions, right, the amount of work they did. And I mean, let's give it a try. Let's render it. So it generated this graph, which is not very helpful, right? First thing is too small, so we can go back here, and I'm going to reduce the zoom a little bit. So I can go back here and say, OK, let's increase the width. That's a little bit better. And we are trying to get this, well, it feels like there are a bunch of dots in here. So maybe our scale is not super good. So I'm going to go here and say, let's try a log scale. OK, that looks better. Let's try that on the other one then. And log. All right, so we have a much better idea of the processes in our system. And the cool thing about smart cells, I mean, this is nothing new, right? You probably saw this happening in a bunch of other places. But there is one really nice thing about smart cells, is that a smart cell, it doesn't change our reproducible workflow. The smart cell cannot interact with our code in any way that is special. All that a smart cell can do is say, hey, I want you to execute this piece of code. You just say, it basically defines the function that we want to execute. And the nice thing about it is that we can actually see what is this function, what is this code that it's running, right? And I can now get it. So for example, say, hey, we want to do a mouse over here, that when I mouse over a point, it tells me the process name. Our smart cell doesn't have this property here, but because it always gives me some code, I can now go look at the code. I can even say, hey, I want to convert this this smart cell to a code cell. And now I can go ahead and change it in any way I want. So it's great because, you know, like me, if you're an Elixir developer that was never really plotting anything before, now I have this UI tool that is going to write the code for me and allow me to learn from it. I can go consult the code, see how it looks like, and now I can maybe mouse over here, try to understand the API that it is using, and use that knowledge to go forward. And the smart cells, anybody can create their own smart cells for whatever. So maybe you want to automate something at your company and you think a smart cell can be good. So let me show another example of what we can do with a smart cell. What if we could define a machine learning model? So what I'm going to do here is that I'm going to create another smart cell for a neural network task. And it starts, again, another UI thing, and it says, OK, what is the task that you want to do? So it has a bunch of tasks, image classification, image to text. So I will try speech to text, OK? Let's see if it works. And then I can choose which model that I have. I'm going to use the Whisper one. So I'm going to evaluate the cell. And what it's going to do, if everything works out, is that it's going to render a form for us, right, to say, hey, if you want to do speech to text, what you need to do is that you need to send me some audio that you're going to convert to text. So let's see if this works. Hello, darkness, my old friend. And I uploaded the audio. I am running now. And it works. Hello, darkness, my old friend. We got it back, right? And they're like, OK, this is really interesting. You know, how does it work? Again, as a smart cell, we can actually go and look at all the code. So we can see here, I'm just going to go over it. So we have a library for loading pre-trained machine learning models, right? So I have the library here. So the first thing that it does is that it's like, OK, I'm going to load the model from OpenAI. I'm going to load everything that is important. And then what it does is that it defines a serving. A serving is something that receives a payload, like an audio, and it's a machine learning specific serving. So it receives some data and return the result of a machine learning task. So a serving in this case is receiving audio and returning the text from that audio. And then the next thing that it does is that it defines, now we can see it defines the inputs. So it defines the audio input, it defines a form, and what it does next is that it's listening to the form events. And if there is an audio, it's going to print something, say, hey, I am running. It's going to convert that audio, send it to the machine learning model, and when it gets the response back, it renders it in place. Again, I don't want to go over all the detail of the code, because the point is that you can actually try it out yourself. You can go home, install Livebook, say, hey, generate a machine learning model, and it's going to give you this. And I even have some video recording showing how I went from this, and I put that into a web application, right, that is now doing speech to text on the fly. Right? And I even show further how we can go from this to a distributed speech to text that would be running in a cluster. Right? And the idea is that Livebook is going to always help you give that first step. And that's the idea of meta-programming, right? So we're thinking, well, if I have a UI, what it means to meta-program in a way. So what I'm thinking here is that we can use the UI to write the code for us, and then we can build and extend on top of that. And you can build any smart cell that you want, and you can upload it as a package to Elixir Package Manager, and anybody can install it, and now they have that workflow too. So if you have a library in Elixir, it can be a great way to teach how other users can use your library. So, and just going back to the architecture, right? We still have the same thing. We have the clients connecting through Livebook for WebSockets. And then the Livebook, the web server, is talking to your runtime, and your code is a process. The branched code from a branched section is a process. And even the smart cell is a process as well that you are interacting with, right? And then at the end, it says, hey, you know, here's the code that represents me, and we can access the code. So it's Erlang VM processes all the way down. So how are we on time? OK, 15 minutes. All right, so that's kind of wanted that's like the bulk of the talk. We talk about how Livebook is metaprogramming, how it works, how the functional aspect is important to provide truly reproducible workflows. And I have a small addendum of things that I am very excited about that I want to share with you that you can do with Livebook. Because for me, it's, like I've been working on Elixir for quite some time. And usually, when I would think how people would use Elixir, I would say, well, they would be using it through a terminal. That's how they would interact with the language. Or maybe they have an IDE, and maybe that IDE could have rich features. But it's hard for me to provide features that are specific to IDEs because there are many of them, right? And have to think, like, it felt very far. But with Livebook, now we have a tool in Elixir that we can really explore, and it's tied to Elixir. So one of the things that we have been doing is, as we add features to Elixir, we're thinking, what would that feature mean inside Livebook? So for example, here is some very straightforward Elixir code. So what this is doing is that I have a string, I remove the exclamation mark, I split this string into words, I reverse and get the first. And then we're using the pipe operator, which basically chains one operation after the other, right? So if I execute this, it's going to get cool, right? That is what is going to return to us. But imagine that for some reason there's something wrong in this pipeline, all right? And you want to debug it, right? So we have, in recent Elixir versions, we introduced something called DBG, which allows you to print a result for you to look at it. And DBG is smart, and it knows that if it's at the end of a pipeline, it prints the result of each step of the pipeline. So you don't have to add DBG yourself to every place. So we're thinking, okay, this is cool when we can see several results on the terminal, but what would it mean to have DBG with rich visualization? So if I do it here now, what we get is that we get this representation of the pipeline that we can see here. And now I can say, oh, okay, depending on what you're doing, what would happen if we didn't do this step? We can see here now that if we disable this step, we would have the exclamation mark. Wait, what would happen if I change the order of those steps? Does it still work? Does it break? Right? So I kind of can explore the ideas. I can change things and get immediate feedback with how that looks like. And then if at the end I'm happy, I can copy the pipeline and put it wherever I want. Something else that we can cool, and it really scales to not only small examples, so it really scales to even complex media. So we have a library called Evision, which is bindings for OpenCV, which is the most known library for doing image manipulation. So here's another example. What if you have, so imagine you have this image, and then you were doing some processing with this image. Let me reduce the zoom, right? Let me reduce more. I don't think it's going to fit. But anyway, the idea is that now you can even play with the image itself. Wait, what if we disable the rotation? How that's going to affect the result? Oh, maybe I should have done the rotation at the end. I can bring it around. I can play with it. I can play with the ideas. Something else that I didn't talk about, that the outputs themselves, we can see here, they can be tabbed. So something like an image does not have only a single representation, right? You can have the actual image. You may want to see the data structure coming from OpenCV, or you may want to see the actual numbers that comprise the image. So you have different representations as well. Another example where we're okay, if we had this thing, how would we do differently? It's regarding documentation and tasks in notebooks. So one of the things that sometimes people say is that notebooks, there are people writing code in notebooks, but it's not really following software engineering principles. There are no tests, for example. And in Elixir, other languages such as Python, we have this idea of doc tests that when you write documentation, right, you can include some examples in your documentation, and we are going to test that those examples, they are up to date, which is great. It provides some basic testing, but it also helps make sure that your documentation is always up to date. So we're thinking, well, maybe we can get all those things together and promote users who are using Livebook to write documentation and to write tests and everything at once. So how would that experience be? So we finished like last week, so this was not released yet, but well, here are some doc tests. I have some very simple function, very simple example. And what happens when I add 1 plus 2 is 3, 1 plus 2 is 4, and I try to do different things. Now when I run the doc test, it gives me the result immediately, right? It's like, oh, this doc test passed, this one failed. So I can go, I can iterate, I can fix the implementation, and again, all the idea of providing a rich feedback and rich visualization to users. So that's what I wanted to share with you today. I hope that if you haven't tried Livebook yet, you're going to try it and see which ideas it can bring to your head. Yeah, this is pretty much it. I'm glad to take questions. Thank you.
Thank you, José, for your talk. Any questions? Okay.
Thanks for the interesting talk. When I saw the metaprogramming portion and how you can inspect some of the past frames or cells, right? I immediately thought the documentation and the tests were also going to be like in the notebook itself, right? So like not in the code, but like isolated, and you can do things with that. Can you elaborate a bit on like the division of how much should be in the code blocks and how much should be in the interpreter or in the environment around it that you have presented?
Can you repeat the question?
Right.
Yeah.
So how much of the codes should be classical written like you've shown here in the end, and how much should be integrated in Livebook, and
how much should be like how much code I write naturally and how much comes from the smart cell or something like that?
Yes, for example.
Yeah. So that's a good question, because I think because Livebook is relatively new, it has not been abused yet. So, like I haven't seen somebody with like a really large notebook where I would say, yeah, maybe you're pushing too much. Maybe you should use like less smart cells or write less code, or maybe because everything, like I just mentioned it, like we have package management integrated. So if you have like a lot of logic that are feeling like it doesn't really belong in the notebook because it's getting complex and you feel it deserves a whole library treatment where I'm going to bring it out, define the whole thing for it, you can do that and then bring it as a package. So I'm trying to get to the point that I'm not sure yet, like what would be the answer to this question. But one of the things that I have been trying to I have been trying to get to tell people is that we are starting to see a lot of solutions which they say, oh, this is like low code or no code, where like you can build like rich applications without necessarily writing any code, just using UI widgets. And one of the problems for that is that if you need to do something that the UI cannot do, you are stuck. You cannot build your application anymore. But one of the things that I want to think about Livebook is that I don't like this idea of no code and low code, because it shouldn't really matter. Like if you're giving a task to do, if you did that for the UI, or you went and you pressed keys in the keyboard, it shouldn't really matter if you got where you wanted to be. So that's where my head is right now. But maybe next year you'll get like a very different answer.
Any more questions?
In the examples you gave, you're writing most of your implementation within this notebook. How good is Livebook at taking some existing library you've written and just showing in the individual cells like example code or?
So how easy it is to get an existing library as a smart cell?
Sure, just any way into the notebook.
Okay. Yeah, sorry, it's because I don't get the audio from the microphone because I'm here. So can you repeat the question? I'm going to get here. Yeah.
Just how simple would it be to take an existing library that I've written outside of Livebook and just show examples of using that library within a notebook?
Okay. Great question. So how easy would be to have an existing library and maybe write a notebook or write a smart cell? I'm going to answer all the possibilities. So in Elixir, we focus a lot about documentation, okay? So and we have like kind of this unified tool and ecosystem and package manager. So if you go to any Elixir package, it's going to have like a documentation thing, most likely the huge majority, and it's kind of all standardized into what you're looking here right now, right? So I picked a random example. And what you can do in the Elixir documentation of a library is that we have the classic API reference. Something that we launched recently is that we have like built-in support for cheat sheets. So for example, like this library comes with cheat sheets that you can go because sometimes you don't want to have the whole API reference, just a quick look at something. So there are a bunch of ways that you can teach somebody how to use a library. And we have usual guides. And one of the things that we did is that, so all notebooks in Livebook, they are called Live Markdown. It's a subset of Markdown, really, which means that they are readable. Which means that anybody can, when they are publishing their library, they can drop this Live Markdown extension on their project documentation, and it's going to be automatically published and treated as Live Markdown. There was an example. I think there was a project which was like, yes, it's a web crawler, and the project name is Spider-Man, so that's a great name. And I think they did that. Yeah, they have a Livebook example here. So that's how it works. And the cool thing is that it detects a Livebook, it adds a button so you can run it on your machine. So that would be one of the ways that you could do it. Like, so you just write a notebook, and you can share that notebook with anyone. You can put it as part of your documentation or not. And if you want to further integrate it, say like, oh, I want to do a smart cell, then we have the mechanisms for defining your own outputs, maybe static or dynamic. There's the whole thing for that. One last thing is that if you go to Livebook, and the homepage here, we have let me reduce the zoom. The homepage here, we have a learn section as well, which has a bunch of documentation on how to use libraries, how to create your own extensions, and so on. Thank you.